Okay, so let's actually start. First of all, welcome everyone and nice to meet you all here today. My name is Orest. I'm Solutions Engineer at StarWind. And the topic of our today webinar is how to easily benefit from ZFS in your IT infrastructure. Now, before we jump to the actual webinar itself, let's just make a short recap on the agenda we have today. So first of all, we're gonna make a short step back and make like an overall recap of what is ZFS. We're going to discuss main use cases where we see ZFS as a perfect fit. We're also going to talk about how it is delivered in the traditional solutions on the market. Then we're going to make a demonstration and talk more about StarWind SAN NAS, its current functionality, and the upcoming features. Then we'll have the actual demo of how StarWind SAN NAS is deployed, and traditionally, in the end, we'll have a short Q&A session to answer your questions. So, what actually is ZFS? Now, ZFS is in fact very well known throughout the industry already. So, besides of being designed for almost infinite scaling of up to 256 quadrillion zettabytes of storage, it's very well known for it being not just an ordinary file system with large scaling. So first of all, it's not just a file system in itself, it's also a volume manager that allows creating RAID arrays, combining your drives in the pool, and add the required resilience to your storage and further expose it at the block or file storage. But again, it's not just the RAID capabilities that ZFS has natively. It's mostly famous because of its data integrity features it has. So the main thing here is that ZFS utilizes copy and write and checksumming to ensure our data integrity. Now, copy and write allows us basically to avoid modifying data in place. So in case if the power outage occurs, our data is either written or not, but it remains in a clean and consistent state, allowing us to safely avoid the write hole. The other mechanism that is responsible for the actual data integrity on all the writes is checksumming. Now, ZFS, as you probably already know, creates checksums on every write operation and then validates on every read. This is what also allows ZFS to become not just resilient, but basically almost impossible to kill, basically providing the highest safety for your data. And finally, ZFS also provides a set of features, making it not just the file system with RAID, but an all-in-one tool you would need for your daily tasks. So these are snapshots, since we are using copy on write, that can be stored locally or sent over a network to the remote server. Also, the duplication and compression that can be set as per the entire Z pool or as per individual data sets or Z volumes. Now, taking all this into the account, what are the perfect, or what we would say ideal use cases for ZFS? Now, first of all, it's of course the file storage usage. ZFS already provides us with SMB and NFS sharing capabilities. So again, you can share an entire Z pool or slice it into the data sets and share them individually with different permissions so that each data set is treated like its own file system with its own rules and settings. Basically, a perfect fit for NAS storage. Next on the list, backups. Of course, to be fair though, pretty much in every use case, the greatest benefit of ZFS is actually its resilience and ability to provide data integrity. So in case of backups, that's the perfect addition to strengthen your 3-to-1 backup strategy with a backup server built on the RAID Z2 array. Plus, the other thing that should be mentioned, we already know ZFS is capable of creating snapshots. Now, snapshots themselves are read-only, and actually immutable, so that once a snapshot is created, nothing can change it. The only thing is that snapshots can be deleted, but this requires either root credentials or user with proper privileges. Moreover, ransomware would need direct access to drives, which is not the case, or not always the case, if we present storage over network, for example, ICE, CASI, SMB, or NFS. And while these are still snapshots only, and to be fair though, they do not replace the proper full backup strategy, this can still be a useful part of your overall backup strategy. Now, media storage. So, of course, ZFS is very popular when used with media storage workloads such as streaming or video editing, again, because of its resilience features. Copy on write, data integrity with checksums, that's all very important when we are having frequent workload, frequent writes, adding of video data. You always need to make sure is consistent and available. Now, however, while the usage is quite obvious, there are several controversial things about ZFS, namely its caching options. Now, ZFS has ARC as the RAM cache, basically read cache, and L2 ARC as read cache extended to SSD, basically to flash storage. Now, the thing is that ARC or L2 ARC is not a read-ahead cache. It's mostly useless for media storage in case we are talking about streaming. Because, for example, once the piece of video or some music has been streamed, we are not visiting it. Only when there is a data set that, for example, doesn't fit it into RAM, but fits into the L2 ARC SSD, and we are doing large amount of random reads on it over and over again, does L2 ARC fit, which again is flash-based read caching. Also, same goes for the write cache. There is no such write caching mechanism in ZFS as traditionally we are used to. So ZFS has the intent log, basically the ZIL, as part of the primary pool, or the S log, again, the extension on the flash storage. And this works only for synchronous operations unless you turn the synchronous property for all writes. So again, might be debatable if the L2 ARC or S log on fast storage will be beneficial if we are talking about the media workload. The best way, in fact, to make sure that ZFS provides good performance, if we are talking about the multiple video editors accessing same data from your NAS, is to slice your Z pool into multiple mirror VDAVs, for example. Since the more VDAVs that we have, the more performance we get in terms of IOPS. And final best use case for ZFS is archive. Now, with archive, it's all pretty much simple. We build our RAID Z2 or RAID Z3 array. We can withstand 2 or even 3 drives failure from the entire Z pool. But we need to remember that ZFS verifies data during reads, basically when it is accessed, which might not be the case with the archive storage. Most likely you would just write it once and never revisit it. So in that case, it's very important to run scrub, either manually, for example, every 2 weeks, or just schedule it using the cron. Now, once we know the ZFS main features and its best use cases, let's actually take a quick look at how ZFS is delivered. Now, I believe this is not a secret. The most famous solution currently on the market would be TrueNAS. Now, TrueNAS is great since it's fully based and has a complete integration with ZFS. It has been designed to be delivered as a bare metal installation, but can also be deployed as a virtual machine on top of your existing virtualized infrastructure. For example, Proxmox, ESXi, or Hyper-V, whenever you want just to create a virtual machine with a convenient NAS operating system that would provide storage sharing. Now, however, to be completely honest, the deployment as a VM might not be that straightforward, but having that said, TrueNAS still provide the most complete and full integration when it comes to ZFS. Another option is Open Media Vault. Now in Open Media Vault, there is no native ZFS integration. However, it is available as a plugin, so pretty much you can still use it. It's also designed to be deployed as a bare metal, but can also be used as a virtual machine. However, both these solutions will require some of the learning curve just to get used to the operating system, management, and other tasks. Now, this leads us basically to the question of what is StarWind SAN and NAS? So since StarWind has a huge experience of decades in the storage virtualization industry, we've designed a product that is aimed to easily fit your existing virtualized infrastructure or a new one, be it VMware vSphere or Hyper-V, and provide SAN and NAS functionality to it. So basically, StarWind SAN NAS is an SDS solution based on the same SDS stack as StarWind Virtual SAN. It is designed to be deployed as a Linux-based virtual machine on VMware ESXi or Microsoft Hyper-V to share storage further over iSCSI, NFS, or SMB. Now, at first, it was indeed specifically designed with the virtualization infrastructure in mind, because it's exceptionally simple to be deployed. Basically, simplicity is one of the cornerstones in our products. So the same goes for the StarWind SAN NAS. Pretty much you do not need a steep learning curve or some additional knowledge. Basically, first run wizard does everything for you in terms of the configuration or of the ZFS pool and creating disks on top of it. Also, it has minimalistic system requirements, allowing StarWind SAN NAS to basically help you repurpose your aging hardware, or of course to be deployed on the new infrastructure, and just give them a new life and use them for SAN or NAS purposes. So again, here are the minimum requirements. These are just 4 vCPUs and 4 GB of RAM. And in case ZFS is used, 8 vCPUs and 16 GB of RAM. Now, I'm mentioning if ZFS is used, since StarWind SAN NAS does not support ZFS only. Pretty much there are a lot of cases where you would like just to have convenient NAS or SAN in your IT infrastructure, but you don't have the HBA, or for example, you have the RAID card that cannot be flashed in the IT mode, meaning into the HBA, and thus making ZFS not the best case, since ZFS needs direct access to drives to make sure its data integrity mechanisms are working properly. So in this case, StarWind SAN NAS also provides support for Linux software RAID and hardware RAID support, making it pretty much a very flexible solution that can fit almost any infrastructure. Now, let's talk about the upcoming feature. So currently, StarWind SAN NAS is deployed on a single ESXi or Hyper-V node as a virtual machine and shares storage further over iSCSI, NFS, or SMB to your compute nodes. Basically, traditional NAS or SAN usage. However, that's not where we are looking to stop at, and we will be going with the bare metal deployment approximately in August 2022, so in the next months. Of course, all the dates here, small disclaimer, are ETAs, so of course the dates are subject to change. So bare metal deployment of StarWind SAN NAS will be available, or should be available, in the August 2022. The deployment as the virtual machine on KVM and as well correspondingly on the Proxmox also in the next months expected. For the cases where we would not just want to share our storage over network to the compute nodes, but also would like to make it highly available, we will also be adding the high availability functionality, basically with active-active replication between SAN and NAS servers in the September 2022 as an estimated time. Also currently in StarWind SAN NAS, SMB and NFS management is done using the text user interface. Now we intend to bring this functionality into the web user interface around of the September 2022. And to add all this, we will also integrate ZFS-based snapshots and NVMe over Fabric support in the fourth quarter of the 2022. Now, let's actually take a look at this StarWind SAN NAS and how it can be deployed. So first of all, let's take a look at our lab today we have. So right here we have a cluster of 2 ESXi nodes. These are nothing more than just 2 compute nodes we will provide a shared storage from SAN NAS to. Now these already have the network connectivity fully set. So you can see we have dedicated virtual switch for management and dedicated virtual switch for iSCSI and data traffic, because that's the one that is not just serving only iSCSI, but also can serve NFS or SMB traffic. And completely mirrored setup on the second compute node. Now we have also a standalone ESXi server where we'll install our SAN and NAS. So let's just log in. Currently, it has nothing more than just the ESXi installation and the local BMFS data store of around 200 GB. All this lab is nested, basically, so these are virtual machines and just serves for the demonstration of StarWind SAN NAS. Now, so the first thing we would need to do is to deploy StarWind SAN NAS. It's delivered as the OVF template, and I have already extracted the files. So let's just give it some convenient naming. Pretty much like that. And select the corresponding files. Let's go further on. That will be on top of our local data store. Here we select the management network and apparently the iSCSI and data network that will serve the actual data traffic. Now on this step, we can already assign all the management and data interface IP addresses. We can skip this process now, and for example, if you have the DHCP server, StarWind SAN NAS virtual machine will grab the DHCP IP address, and then you can change it using the text user interface. But for the sake of simplicity, let's actually configure this now. Again, let's make a convenient host name. Let's set the IP address. Network mask, gateway, and DNS. And now let's also configure the IP address for our data connection. That will be just the private network. And also 24 mask. We'll set the MTU straight away. And let's actually, enable SSH connectivity. And let's deploy. The deployment of the OVF template will take a couple of minutes, so let's just give it some time to proceed and finish the deployment. Also, to be completely fair, since I mentioned this is the nested lab, for our ZFS pool inside SAN NAS, I'm just gonna grab drives from the local BMFS data store. Basically, I'm just gonna attach several VMDK files to the StarWind virtual machine just for demonstration, but again, we should remember if we are using ZFS in a proper environment, we would add storage either as raw device mapping for individual drives or the HBA or RAID controller PCIe pass-through in the IT mode. For ZFS, again, to have direct access to our storage. Okay, and the deployment seems to be complete. StarWind SAN NAS virtual machine is getting started. Yep, there it is. Meanwhile, let me just add a couple of VMDKs so that we could combine our storage in the redundant pool. Let's just add 4 drives, 16 GB each. Well, let's make it 20 to be beautiful. This will be completely enough for the small demonstration. And as you can see, VM network and iSCSI is already there. Now let's save. The task should be completed, and let's log in to our SAN NAS virtual machine. And we are welcomed by the first run wizard. So basically, the goal of this first run wizard is to basically make the entire configuration that is fully ready to share the storage over the iSCSI. Now, NFS and SMB are configured currently separately in the text user interface, but will also be available as part of the management in the web user interface in the upcoming releases. So let's go next. Let's upload our license file. Okay, it checked it. Read and, of course, accept the end user license agreement. And here we can set, and basically we need to set the specific password for the administrator account to avoid using any default passwords. Okay. Now, at this point, we can skip the further setup. The further setup basically includes, as you can see, adding disks, setting the pool name, creating the actual pool, either ZFS or MD RAID pool, configuring hot spares, and creating virtual disks. So again, this can be skipped and you can then do it all manually, but we recommend using the first run wizard to make the deployment as simple as possible. So let's proceed. And we'll need to rescan storage for StarWind SAN NAS to see our recently added 4 VMDKs. Okay, good. 4 disks attached. Now let's set up the name. Since I intend to create the ZFS pool, I'm going to name it just as like that. Now, when we first hit the creation pool, the pool creation step, we get the advised storage pool profile or layout. Currently, it's capacity recommended with the RAID Z2. So you can see we have one group with 4 disks per group. A bit lower, we can see which drives are selected, their capacity, resulting usable capacity if we select set 80% limit for pool capacity utilization. As we know, ZFS doesn't really like when the pool gets fully utilized. If the pool is more than 80%, usually it tends to get lower performance. This might not always be the case, but if you want to be completely safe from this, from the performance degradation, you can already set to the 80% utilization limit. Or uncheck this box and get pretty much the full capacity. So the other option is to go for the manual configuration. With manual layout, we get much more of the options. These are stripe, mirror, RAID 5, and the RAID configurations just as well, including RAID 1, RAID 5, RAID 6, and RAID 10. Currently, in our case, hardware RAID is not applicable, and striped RAID Z2 or RAID Z1 configurations are not applicable as well, since we have just 4 disks. But this allows for the granular control if you want to set your own ZFS pool settings. But currently, let's go with the capacity recommended and RAID Z2 layout, and let's keep the 80% limit. Now, we will need to validate the layout to make sure everything is selected properly. Great. Let's go next. On this step, we can assign hot spares if there are any. In my case, there are no, so we're just going to skip this. Creating virtual disk. Now, as I mentioned, StarWind SAN NAS is based on the SDS engine from the StarWind Virtual SAN. So creation of the virtual disk is the actual creation of StarWind image file that will be shared over the iSCSI. So let's make a name for it. StarWind disk, as simple as that. Let's just go for 20 gigs as an example. Next, on this step, if required, we can make changes to our management or iSCSI interface networks, change the IP addresses or network mask. Currently, all is good. So let's just proceed. Then finalize the configuration, make sure everything is as we planned. And let's actually create our ZFS pool. So around 2 minutes remaining, and let's wait it to be completed. Also, in case if we are talking about the VMware vSphere and my current setup, to simplify the management of StarWind SAN NAS in the vSphere environment, especially if you have compute nodes joined into the vCenter cluster, as we currently have, StarWind provides us with the vCenter plugin. So when we just finish our configuration, the next window will tell us that we can install the vSphere plugin straight away, and which we will actually do. Make sure we meet the prerequisites. Now, let's enter the IP address of the vCenter server, basically of the vCenter appliance. Username, and of course, password. Now, and we should be fine. The certificate warning, revisit, revise the information, and let's do the install. The install is very quick, takes around 30 seconds, maybe even less. And it's ready. Let's go on. Congrats, we have the vCenter plugin already installed. We can open the plugin page. It will basically open the new vSphere cluster window. So I'm just going to close the duplicate one. So the vCenter plugin is loaded, and what we have here is pretty much the full management of the StarWind SAN NAS. Now, if we would go the traditional way, you would hit the web user interface. And you can see these are identical. Now, let's proceed further from the plugin. So on the dashboard tab, the information we get is, of course, the overall system information, operating system version. Currently, as you see, Ubuntu 20.04, StarWind service build version, license, system uptime. We also get the information of the device's high availability, and since I have small screen here, let's move on for the web console. Yep, that will be better. So the virtual disk's availability, high availability, is currently showed as unavailable, which is true. It will be added in the upcoming releases. Limited availability, also not applicable, since limited availability means that part of your storage is offline. And of course, we get the information on CPU, RAM, and storage utilization, plus the performance metrics for the IOPS, disk throughput, and network throughput. As you can see, nothing really is going on there. Storage tab is where we can manage our disks, create new pools if we decide to add more drives to StarWind SAN NAS, or added settings of the existing pools, and also create more StarWind virtual disks on top. On networking tab is where we configure our networks, assign the IP addresses, and tasks and events tab is basically what shows us what tasks we're running and if there are warnings or any critical events. Now, if we go also to the settings, we can check the general information, perform the power management of StarWind SAN NAS, upgrade the license if required, collect the support bundle, and basically make any changes if needed. vCenter plugin shows us that it is installed, which is true, and the updater. Currently, this is the latest version. Proactive support is currently grayed out tab and will be available in the upcoming releases when we'll fully integrate the proactive support monitoring capabilities into StarWind SAN NAS. And just the same functionality is available inside of the vCenter plugin. Now, basically, that's it for the StarWind SAN NAS deployment. The next, what we just need to do is basically connect our iSCSI disk to our compute nodes. So let's go for the iSCSI software adapter. I already have it added. Let's add first the dynamic pass. And this is the IP address assigned for the data iSCSI interface. Let's do the rescan. And we should see one pass active and our StarWind iSCSI disk available. Let's just do the same on the partner node. Same IP address. Another rescan. And again, one pass and same StarWind iSCSI disk available. Next, we can just create data store on top. So let's actually do this. Let's quickly create a VMFS data store. Let's name it StarWind data store. I'm going to select one of the nodes. we have StarWind SAN NAS here, VMFS 6, of course, and yeah, for the full size. And here we have our StarWind data store waiting to put some workloads on it. And if we check the second node, it also has connection to the shared storage. Now, as I mentioned previously, creation of the NFS and SMB shares is done using the text user interface. Now, this can be just done by launching the console of our VM or the SSH client remotely. So let's go with just the most simple option. We're going to log in and enter the password we have set previously. Here we can also perform all the changes for the management network connectivity if required, change our password, configure NFS and SMB shares, remove our shares, disable or enable SSH, also terminal if required for more granular control over ZFS, for example, and also to collect the support bundle if that is needed. So since we're talking VMware vSphere today, let's configure NFS share. We select our ZFS pool. If there are multiple pools, of course, you will have a list of available pools and select one of them to create NFS share. Now let's make a convenient name. For example, StarWind share. Let's go next. By default, this will be allowed for all the IP addresses range. Otherwise, you can set the dedicated IP addresses for NFS sharing. Let's go with default. Check the settings. And here is our mount point. MNT, NFS, StarWind share. So let's go to our vSphere cluster. And once again, add new data store, but this time it will be NFS version 4, StarWind share, our mount point, and the IP address of StarWind SAN NAS. Let's add. Currently, I won't use any Kerberos authentication, and I will connect both of our nodes to the NFS share, and you can see it's just instantly available, waiting for us just to put some data on it. It would be the great time now for the questions. So if any, please ask them in the question section. And as far as I understand, there are no questions, at least at this moment. At this point, I would like to conclude our webinar and tell huge thanks everyone for dedicating your time in joining this webinar. Have a good rest of the week and a great weekend, and keep safe, and hope to meet you soon on our next and upcoming webinars. Goodbye.